reactances and capacitances. Resistance reactance, capacitive reactance and inductive reactance. In the last class we discussed about capacitor, inductor, resistance, RLC parameters. What is the resistance, inductance and capacitance. Now similarly reactance. Reactance is also similar to resistance. The unit of reactance is ohm. Reactance unit is ohm. Resistance unit also ohm. The resistance unit also ohm. What is meant by reactance? It is the property of a element which opposes the current, similar to resistance. What is the definition of resistance? So that is same we can apply for reactance also. Reactances are two types. One is inductive reactance and capacitive reactance. Inductive reactance and capacitive reactance, two these. Inductor offers inductive reactance when it is subjected to alternating current. Alternating current, when you apply for inductor, then only it produces inductive reactance. That is the formula to calculate inductive reactance is 2 pi Fl. 2 pi Fl, where F is known as frequency. Frequency, if it is 0, for DC frequency is 0. Because DC does not vary with respect to time, number of cycles are 0 in case of DC. But in case of AC, number of cycles will be present. It is one cycle, it is also one cycle. Like that, it is a time period T and magnitude of quantity on y-axis if you consider. For DC, frequency is 0, number of cycles per second, it is one cycle, number of cycles per second is 0, hence inductive reactance will become 0 for DC. For DC, frequency equals 0, if you substitute frequency equals 0, it is 0 for DC, inductive reactance. Capacitive reactance, it is the reactance offered by the capacitive element in the circuit. Whenever AC current is applied to capacitor, then it opposes the current. The property is called as capacitive reactance. To calculate capacitive reactance, we have to use this formula, omega C. 1 by omega C or 1 by 2 pi Fc. 1 by 2 pi Fc. Again, capacitive reactance also depends on frequency. Capacitive reactance also depends on frequency. For DC, frequency is 0 and X equal to 1 by 0, it is infinite. 1 by 0 is infinite. For DC again, if you apply for capacitor, inductor, if you apply the DC for inductor, then frequency is 0, inductive reactance also 0, because frequency is 0. But of course the inductance value is there, but frequency is 0, multiplying anything with 0, it is 0. That means inductive reactance and capacitive reactance for DC, it is 0, it is infinite. The reactance, both the units are ohms only. The units of inductive reactance and capacitive reactance, both the units are ohms only. Resistance also ohm, but how to calculate this formula is very, very important until we are studying electronics and communication engineering or electrical engineering subject. What frequency response also will come in second year, third year, final year. These formulas we have to remember for longer duration. These formulas we have to remember until your course is completed, B.Tech course. Okay. These are the topics we discussed previously. And one more thing we discussed that for capacitor, if the capacitor is subjected to this voltage V, it is a capacitor C, then what is the voltage and current relationships we discussed previously? Voltage and current relationships. I equal to C dV by dt. This is the current through a capacitor. Current through a capacitor. I equal to C dV by dV by dt. How we obtain this? That we discussed in the previous class. We know that current is nothing but dq by dt. A capacitor having a charge Q equal to CV. Q equal to CV. That formula we derived in the last class. If you substitute in place of Q, the current in the sense flow of charges. Flow of charges is nothing but current. dq by dt, if you substitute C dV by dt, finally you will get I equal to C dV by dt. Then dV by dt equal to 0 for a constant. If V is constant in the sense DC. It is not varying with respect to time. It is constant over a period of time. Suppose in a time on the x-axis we consider a time, then it is a constant magnitude of DC quantity. Hence, if the constant of differentiation becomes, differentiation of any constant is 0. Differentiation of any constant, you studied or not? Differentiation of any constant is 0. Then I equal to C into dV by dt becomes 0. Because for DC it is 0, differentiation. But for AC it will happen. It will be there, dV by dt. According to the charge of capacitor, it varies for AC. I equal to C into 0, that is 0. That means current equal to 0 in the capacitor. For a DC voltage, if you apply DC for a capacitor, current becomes 0. Current is 0 in the sense it is not connected, it is open circuit. Current, open circuit and short circuit, you know. Short circuit in the sense heavy current. Due to short circuit only most of the electrical appliances getting damaged. Due to short circuit. Short circuit in the sense current will be maximum. Current will be maximum, voltage will become 0 in short circuit. Open circuit in the sense opposite of that. Current is 0, voltage will be maximum. These are the things you have to remember. Inductor acts as open circuit for DC. How can we say that? Based on this current relationship in a capacitor, I equal to C dV by dt, we obtained, we given the notes also in the last class. I equal to C dV by dt. If you substitute here 0, because constant, for DC it is a constant V. Differentiation of that becomes 0, hence I equal to 0. I equal to 0 means it is an open circuit. Voltage will be maximum. Of course, we applied the voltage, but capacitor acts as open circuit. It won't allow current. Open circuit it is. Capacitor acts as open circuit, inductor acts as short circuit for DC. That is the thing we derived previously. How can we say that capacitor, inductor acts as, suppose if you consider inductor is connected to a DC supply. An inductor is connected to DC supply of that. Then what is the current relationship? V equal to L di by dt. Di by dt is constant. Di by dt, I is the constant for DC. Whether it may be voltage, suppose voltage is 10 volts, current may be 2 amps. Same current. Magnitude will be different. Voltage is maximum 10 volts, then current will be 2 amps, like that if you consider. Again, current also constant with respect to time. At that moment, what will happen? Di by dt becomes 0. Voltage is 0. If voltage is 0, what is this? Voltage is 0 means short circuit. Inductor acts as short circuit for DC. Okay, inductor and capacitor both will be works on only AC. Only AC it is. Because I equal to 0, open circuit it is capacitor, inductor as short circuit, that we have to remember. The basic, what is the fundamentals of electrical circuits? Basic elements are 3: resistor, inductor, capacitor. What are the definitions? What it acts? That we discussed previously. Inductor stores the energy in the form of electromagnetic field. Capacitor stores the energy in the form of electric field. Capacitor has units farads, inductor has units henries, not webers. Flux has webers. Okay. Then we derive what is the inductance, flux linkage per unit current. It is known as the inductance. Some formula we derive inductance, how to indicate inductance and resistance and capacitance, capacitive reactance, inductive reactance. That is XL and XC is nothing but inductive reactance. The reactance offered by capacitor is known as capacitive reactance. The inductance offered by inductor. The inductive reactance offered by inductor is known as inductive reactance. The reactance, basically reactance is similar to resistance. Reactance will appear in only AC. alternating current only, because frequency will be there. Reactance always depends on frequency. If frequency is 0, reactance becomes 0. In DC, reactance will not be there, only resistance will be there. Reactance term will come in impedance. Impedance Z. Impedance will appear in only AC circuits. Z equal to R plus JXL. The formula to calculate impedance. Z is defined as impedance. Impedance is similar to resistance. Impedance or units also ohm. Again, impedance unit also ohm. Reactance unit also ohm. Resistance unit also ohm. But where we are using resistance, where we are using reactance, that is the difference. Okay. Impedance, so many units are ohm only. Okay. For number of for resistance, ohm, reactance ohm, capacitor reactance also ohm, impedance also ohm. What is meant by impedance? Let us write impedance. Impedance of any circuit is defined as impedance of a circuit is defined as magnetic impedance. The letter is Z. It is the combination of resistance and reactance. Right now, it is the combination of resistance and reactance. It is the combination of resistance and reactance, and expressed as complex form. It is a complex form or not? Complex form it is. Complex numbers, you know that, different types. Okay, it is a complex form and expressed as in complex form Z equal to R plus JXL. Z equal to R plus JXL. Suppose R and L both are there in any circuit. R and L both are there, then the impedance of this circuit is Z equal to R plus JXL. If capacitor is there, minus will come. Okay, later on we will discuss what is capacitor, R plus JXL, why it is only plus, why it is not minus. That we will discuss. By capacitor and resistor, inductor, 3 are in series, then R plus JXL. XL minus XC will come. If XL is 0, R plus, suppose a capacitor also there. See, capacitor having reactance. Capacitor reactance XC. Then the impedance is defined as R plus JXL minus XC. JXL minus XC. If there is no inductor, inductive reactance becomes 0. XL is inductive reactance. R plus J 0 minus XC, then R minus JXC. If capacitor and resistor both are present in any circuit, then the impedance offered by that circuit is given by Z equal to R minus JXC. Is it right? If both are there, we have to consider this XL minus XC. Okay, again we will discuss what is impedance in AC circuits. Okay, this is nothing but various terms are related to elements: resistor, inductor, capacitor. Okay. Now, if the resistors are connected in series and parallel, you already studied in 10th or intermediate. The resistor connected in series, resistance connected in parallel. That we will discuss in this. Making resistances in parallel and resistance in series, or difference between resistances in series and parallel. difference between resistances if they are connected in series. What are the formulas? How to do calculation of this? It is very important to solve the network reduction techniques. The basics which we are studying here up to now, that is very important for entire subject. Those who are absent for previous classes, those who are newly joined, take the notes and prepare according to that. Okay, make it in serial number, resistances in series. Resistances in series, and another one is resistances in parallel. You know, already you studied in intermediate or SSC what is the resistance, total resistance in series and total resistance in parallel. What is meant by series resistances? Number of resistors are connected end to end, then it is called series resistance. Suppose this is one resistor, this is another resistor, this is another resistor. The end of one resistor is connected to starting end of another resistor, then it is connected in series. The end of one resistor is starting end of another resistor, then it is connected in series. Similarly, this is R1 is one resistor, RP is one resistor, R3 is one resistor. If they are connected in series like this, the voltage which you apply plus and minus DC voltage. These resistors are connected to be in series. Similarly, what is meant by parallel resistors? First we have to write, draw the table. Draw the table, serial number, resistances in series, parallel. Series and parallel circuits of resistances like this. If the resistors are connected end to end, then those are said to be in series. Then what is parallel? If the resistors are connected parallel across each other, then suppose if it is one resistor R1, R2, R3, these are the three resistors. How to connect parallel? Across, we have to connect. The two ends will be joined together across each other. It is end-to-end connection. It is across. Across in the sense parallel. Across in the sense parallel. Understand this? Across in the sense parallel. Suppose one person is moving. Okay, one person is moving. Behind that person, if another person is moving, running, it is series. Instead of moving in behind, if the person is moving across, then it is parallelly they are moving. That is right. Parallelly. Suppose you can see parallel combination where you can see if two flights are moving same height, these are connected in parallel. They are moving parallel. Across in the sense it is parallel. If the resistors are said to be in parallel when they connected across each other. If the resistors are said to be in series when they are connected end to end. That is the series resistors. What is the difference between series and parallel voltage and currents? That we have to know first. In series, which is constant, the same current will enter all the resistances. Current, suppose a DC voltage is applied for this circuit, V plus and minus a DC that is applied. Then current flow through all the three resistors are same. I is the current. Current I is flowing in this resistances. Then current is constant or current is same across all the resistors. The current flow is same. But here, suppose if it is connected to a DC source like this, plus and minus is a battery, a source, DC voltage source, then current will flow here, total current, but current will divide in parallel into three ways, I1, I2, I3, like that. If the currents are divided, they are said to be in parallel. That is simple. Okay, right. Series. The elements are said to be in series. Right. Under this, right. The elements are said to be in series. The elements are said to be in series if they are connected in. The elements are said to be in series if they are connected in end to end, one after another. That is series. Under parallel, you can write that if the elements are said to be parallel, if they are connected across each other. Next, how can we draw? You can draw this diagram. It is the resistors are connected in series, resistors are connected in parallel. Okay. Across each other. Resistors are said to be in parallel when they are connected across each other. It is across, it is end to end. It is nothing but series, it is nothing but parallel. Parallel in the sense across. Okay. Next. Current will be same. You can represent second point. First point is the definition of circuit is second point. Third point is current I is same in all resistors. Current will be same. But here third point is current is different. Current is different in three resistors. That means that is current divide. Current division is possible in parallel. Current is divided. Right. Current is differed. Current is differed in three resistors. I1, I2, I3. Next line, you can write. Current will be divided into three parts here, or current division is possible. Current division is possible in parallel. In parallel, current will be divided into number of paths. It is one path, it is another path, it is another path. Current will be divided. Okay, next one. In series, voltage will be divided. Current will be same. Voltage across this resistor, voltage across this resistor, voltage across this resistor. Across in the sense parallel. Parallel, or if you say this is V1, it is V2. So it is the V2. Voltage across resistor 2 is V2. Voltage will be differed in series. Voltage drop, it is also called as. Voltage drop according to Ohm's law, V1 equal to I1 R1. I is constant, I1 equal to I2 equal to I in series. According to Ohm's law, we can say that V1 equal to I1 R1. I1 equal to I. I1 equal to I. I2 equal to I. I3 equal to I. Suppose the current entering the resistor 3 is I3 equal to I. Current is same. According to Ohm's law, we can say that voltage drop across resistor R1 is V1 equal to I1 into R1. Similarly, V2 equal to I2 into R2, I3 into R3. But I is same, I into R1, I into R2, I into R3. You can write like this because according to Ohm's law. Okay, voltage will be different. Based on resistance value, it will be different. R1 is not equal to R2. If R1 is not equal to R2, then it will be different. Voltage will be divided. Voltage is divided. Okay, right now. Next, fourth point. Fourth point. Voltage will be divided. Voltage will be divided in series circuit. Voltage will be divided in series circuit. That equal to V1 equal to I1 R1, or that equal to I into R1. You can represent in the circuit. In the same manner you can represent V1 equal to I into R1. V2 equal to I into R2, V3 equal to I into R3. According to KVL we will discuss later. Based on that, total voltage equal to V equal to all the voltage drops, V1 plus, V2 plus, V3. That equal to V equal to V1 is I1 R1 plus V2 is I R2 plus V3 is IR3 in series. V equal to I is made common, I is constant, I is same, I into R1 plus R2 plus R3. We can write I equal to V equal to I into R1 plus R2 plus R3, where R1 plus R2 plus R3 is the total resistance. We can again obtain Ohm's law. Okay, V equal to I into R1 plus R2 plus R3. But here current will be divided. You can write fourth point. Current is divided. Again we can write voltage is constant. In parallel voltage will be constant. Voltage will be same. Right? Voltage is same across all the resistors. Voltage will be same across all the resistors. That means V1 equal to V2 equal to V3. Parallel voltage same, but current is different. Voltage is same in all resistors, across all resistors. That is the fourth point. Next, similarly we can represent KVL also. Next one, what is the total resistance? Right. In series, total resistance or equivalent resistance, it is also called as total resistance or equivalent resistance. Equivalent resistance or equivalent equal to R1 plus R2 plus R3. In parallel, R equivalent equal to 1 by R1 plus 1 by R2 plus 1 by R3. Next point, fifth point, it is total resistance in series circuit is R1 plus R2 plus R3. But in parallel, 1 by R1 plus 1 by R2 plus 1 by R3. But if there is a mistake is there. 1 by R equivalent equal to this. You studied in 10th or intermediate this one. 1 by R equivalent equal to 1 by R1 plus 1 by R2 plus 1 by R3. If you want R equivalent, what we have to do? 1 by R equivalent equal to R1, R2, R3 is the LCM. R2, R3 plus R1, R3 plus R1, R2. R equivalent equal to. Next, if you want R equivalent, it is 1 by R equivalent. R equivalent equal to R equivalent equal to reciprocal. R1, R2, R3 by again R2, R3 plus R1, R3 plus R1, R2. This is the R equivalent. But in resistor series it is simple. R1 plus R2 plus R3. This is the R equivalent. Our total resistance is given by. Suppose if two resistors are there. Suppose R equivalent of two resistors is R1 R2 by R1 plus R2. If two resistors are there, suppose two resistors are there, R equivalent equal to R1 R2 by R1 plus R2. If two resistors are there. Voltage is said to be same. So the parallel circuit, voltage will be constant or voltage will be same. But which is differ? I. Total current I in this 6 point current I is same. Current is I is same in all resistors. All resistors. But in case of parallel, current is not same. It is the sum of all currents. Right? Under this radar, parallel current is not same. Current I equal to total current I equal to I1 plus I2 plus I3. I1 plus I2 plus I3. Here I1 equal to I2 equal to I3 equal to I. Current will be same. Current will be the sum of three currents. Total current equal to. Total current I equal to three resistors. What is the current flowing? That we have to add. Okay, that is the parallel. These are the differences between resistors in parallel and series. And network reduction techniques we are using these formulas. R equivalent resistors in series and resistors in parallel. Next class we go for network reduction and circuit reduction. Suppose the resistors are number of resistors like this. One resistor, and another resistor, and another resistor is connected like this, and another resistor is connected like this. We have to, these are in parallel, it is in series again, combination will be parallel, like that. Network, it is nothing but network. Connection of various elements, various resistors. How to reduce the network into single network? Equivalent resistance, it is R1, 2, 3, 4, 5 ohm. Ohms are resistors are represented as ohm. If you reduce equivalent resistance, how to calculate? Because we have to know resistors connected in series and parallel. This concept is important for next class.